Yep, good to go.
Good. So, yeah, I would say welcome in this session on Azure Business Continuity and Disaster Recovery. So, as most of you know, I'm working for Microsoft, no secrets there. And what I did 4 years ago was part of Azure CAT, so it's a customer advisory team. And in meantime, I moved to worldwide learning. And in between, I actually went back for a few years running my own business. So I was running my own business, moved to Microsoft for a few years back, then left Microsoft, and eventually last year, September, joined them again. And I'm currently part of the Azure technical training team all over the world, but based out of Belgium. And somehow I think this is a benefit, at least one of the only positive things we have with COVID, that I'm not traveling at all. And this gives me the opportunity to present for your group in a bit easier way than what I normally would do because I'm not traveling that much anymore. And it would just be hard to literally come over. So this is a little bit positive. So my main goal is guiding you through a couple of base concepts, like what are the built-in tools that we have in the Azure platform that allow you to safeguard your environments from infrastructure, platform services, a little bit on serverless, and in between trying to do as many demos as possible, and a little surprise all the way at the end. So if you got any questions, I'm aiming for about 60 minutes, so we should have some time for Q&A at the end, but feel free to send them already in the chat box if you want, and then I'll make sure I can answer them. And even afterwards, or for the ones who are not joining live, and you're hearing this as a recording, don't hesitate reaching out. I'm all over the place. So Twitter is my preference, but feel free to leave an email as well. So the agenda quite straightforward: business continuity, which technically means a backup solution and a disaster recovery solution. And I'll talk a little bit about the differences between those two, where the biggest part will be IaaS, because most of the public cloud customers are probably running in hybrid, and moving virtual machines is still one of the most popular ways to use public cloud. But at the same time, also talking about how to back up anything that's running on the PaaS platform like web apps, SQL, Azure, or any other database as a service. And I'm skipping file sync. It's in here, and I do have some slides, but I'm not going to show them because we're not having all the time. And I want to make sure that I can walk you through most of the demos to just show you how it works. I'll make sure that you get the slides afterwards. I'll send a PDF document to Niraj, and then he can probably share it somewhere on the meetup or in any other way. So, but you know what I'm doing. So, technical trainer within the Azure Microsoft team, and Microsoft certified trainer for longer than I remember, I think 12, 13 years in meantime. And before I joined Microsoft, I was an Azure MVP for almost 6 years. So Azure is, I would say my playground. So the Azure Pack scenario helped me getting into public cloud. My background was infrastructure, so deployed Microsoft-based data center technology for, I think, 12, 14 years, and then totally switched to cloud. And the last time I touched a physical server, I think, was like 6 years ago. And as you heard, I initially wrote a book, was my third one at that time, Azure Backup, Azure Site Recovery and Monitoring. And I'm still doing it. So I think I'm currently writing book number 7, and that's on Azure Infrastructure as Code. So the end-to-end automation using deployment templates. And it should be out somewhere, hopefully September. So a bit more to the technical parts. So when you think about your own organization, or if some of you are working for a partner, you probably talk to the business, CTO, CIO, and whenever you want to open up the conversation around disaster recovery or like what's the high availability you want, they tell you like we need 100% high availability. Now it means nobody can move to public cloud. And technically it also means that nobody can actually run a data center because there's no such thing as 100% high availability. You can get pretty close to 100%, but it's never gonna be the full 100% because even if your system, your data center, your workload is down for a few seconds, it's not 100%. So using the first biggest part in the workloads we run on Azure is virtual machines. So when you deploy an Azure virtual machine, the default SLA is 99.9. It's roughly 45 minutes potential downtime. So if you have a more business critical workload, you need to move to a different architecture. And then you got two different options, availability sets and availability zones. Now, what's the main difference? In an availability set, you're going to deploy two or more identical virtual machines. Think of two web servers, two domain controllers, two database servers. That's the scenario. Where out of your deployment option, where you define I'm going to run it inside an availability set, you're going to unlock some kind of intelligence in the Azure platform where we're going to validate that your additional virtual machine instance is never running on the same physical rack. Now, it might be a little bit easier if I just switch to my whiteboard, if it wants. So let's say this is my Azure environment. So the whiteboard for now is an Azure region. So this is Charlotte, let me guess, East US, Azure region, where each and every Azure region has a whole bunch of physical racks. So I always joke about the fact that an Azure data center is nothing different than your own data center. It's just a little bit bigger, but it's based on physical components, which means down in the physical rack, you got your storage. On top, we have the network connectivity like switches, fiber connectivity, everything. And in the middle, we got the physical servers. So when you deploy your virtual machine, it's gonna land on some physical server. So this is your virtual machine connecting to network, high available on the virtual switch, and connecting to storage. So when you deploy your Azure VM in option one, just standalone virtual machine, it's not super high available, which is perfectly fine for a lot of scenarios. But for a few other ones, you need to come up with a different design. So that's where we're going to deploy a second virtual machine, an identical one, as part of an availability set. Now, what is an availability set? It's a setting in your virtual machine deployment where you're going to unlock intelligence that every virtual machine instance that you're going to deploy within the same availability set will always be deployed on a different physical server in the platform. And obviously, the uptime goes up a lot because we can cover downtime from the physical server. Well, first of all, the virtual machine, the physical server, the physical rack, and that's what moves up the SLA. But it's not 100% solid because if we zoom out a little bit, an Azure region, let's pick another color, is based on buildings. So this could be building 1, and simplifying it a little bit, building 2 and building 5, or I have no idea how many buildings we have in each and every region, but that's the idea. So it could be, luckily it doesn't happen too much, but technically it could still be that a building becomes unavailable, which means typically no power, no cooling, no network connectivity. That would be the main point of failure. So which means if we look at the same scenario, so the black boxes are the physical racks. Let's not the best physical rec, but that's fine. So what we can offer you is another option where we're going to deploy the same web server. So again, at least 2 instances or more in a concept, and I'm going to use this scenario that we call an availability zone, where you deploy your workload here and your workload here in a different building in the same region. And that's where the difference in SLA comes from. So easy said, if you want ultimate high availability, so the 4 nines, it's I think less than 25 seconds downtime or potential downtime a month, then you would deploy your setup in an availability zone. So coming back to your Kubernetes topic, we don't offer you built-in backup solutions, but when you deploy a Kubernetes cluster, the recommendation is to deploy it in an availability zone to make it high available and redundant. Now, the other thing about Azure is that everything is region-based. So the ultimate idea would be to deploy the exact same setup in a different region. So you would, again, pick an availability zone setup in a region, I don't know, central US maybe. And from here, building up the same thing. So physical racks, and in between here, your virtual machines. So that's the high availability. And that gives me the advantage to skip a few boring slides, but I'll provide them anyway. So that's the physical rack design, where with the availability set, you specify that it's never going to run on the same physical rack. And obviously, at some point in time, there's going to be some overlap. If you deploy like 1,000 virtual machines, identical ones in an availability set, then most probably at some point in time, you got a few virtual machines running on the same physical rack. There's no way around it. But I don't have any real use case to deploy 1,000 identical servers in one single building. So that's already wrong by design from the beginning. The other thing is that availability zones are not really new anymore, but they're not available in all Azure regions. And I think we moved up to 61 only a few weeks ago. So they're not available all over the globe, which might be important if you're outside of the US. So multiple zones in one region, and then what I explained on the whiteboard, moving it out to multiple regions. And that works fine, but the downside is that it's quite expensive, because if you look at this architecture, let's say each and every scale set is running a functionality like a web front end, a database server, and maybe domain controllers. It means that you got 8 copies for that one single instance, which could become quite expensive. And that's why I'm going to talk about other solutions later on, obviously. So that's the virtual machines. Now, the second important component in the platform when you're building VMs is underlying storage. So the SLA for the virtual machine is not covering everything. That's the core message. So when you deploy Azure storage, when you're going to create your virtual disks, you also need to design your storage architecture. And pretty in line with availability sets and zones, we give you storage replication. So you got local storage that's providing 3 copies in the same data center, so in the same building. Zone redundant in line with availability zones. Every now and then we are a little bit logic. So providing 3 copies in the same Azure region in different buildings. And if you want to replicate your storage across multiple regions, you're going to use the GRS, global or geo redundant storage. So those are the baseline. There are a few side paths where you get local zone redundant and some other options. I think you got 4 or 5 different options in meantime, but most customers are still going for I would say the more traditional ones. And what it means, if I switch back to the design, it means that with local redundant, I got one copy here, a second copy in probably the same physical rack, and the third copy in a different physical rack, where again the idea is if we lose a physical server or the physical rack, we still have a copy available. And then availability zones, mapping it with zone redundant storage. We have a copy in one building and a copy of the storage in another building. And the total is always 3. And then geo-redundant, where we're going to keep 3 copies in a different region and 3 copies in the local region. So that's also giving you ultimate high availability. I don't have a fancy demo because it's quite hard to mimic a failure in an Azure data center, but I can show you how you define it. So if you create a new virtual machine, Windows or Linux or anything from the marketplace, doesn't really matter. You deploy it from here or CLI, PowerShell, Azure templates, Terraform, Pulumi, I mean, any tool you want. Where down here, already from the initial deployment, that's quite important, you need to specify what kind of redundancy you want to use. So it means that if you deploy a standalone virtual machine and later on your manager or the business defines that it's becoming a more business critical workload, you cannot squeeze it into an availability set or zone. So the workaround is stopping the VM, disconnecting the storage, creating a new VM resource, and defining that it's running in a set or a zone and connecting to the existing disk. So that's a little workaround there, but it's technically doable. Now this is all about high availability. Now what's the negative point about high availability? That you're wasting resources, because you got, like in my example, you run one website, or one web server, one database server, some middleware, domain controller, anything else in the workload, and you're going to duplicate at least 4 times. And if you want to make it high available in each and every layer of the platform, you're going to end up with 8 copies. So that's literally wasting money. And that's where we're going to move to disaster recovery. The downside with disaster recovery is that most of the time it's down, and it means there's downtime. So that's the main difference. Now, quite important, backup as one of the disaster recovery tools is not the same as high availability. So again, high availability, everything is up and running probably all the time or as close as possible, where business continuity and disaster recovery is involving downtime. So something happens, there's an earthquake, we lose servers, we lose data, connectivity, we lose physical racks, we lose power, those kind of scenarios. Or the oops admin, like I'm logging onto the Azure portal and I'm deploying a ARM template and I made a mistake, and instead of deploying something new, it's actually wiping anything that I already have in my resource group. And I'm talking from a real life experience there. So that's where you need to come up with a backup solution that allows you to recover. Where easy said in Azure, and we're still in virtual machine scenarios, you got 2 options. The first is Azure Backup, and easy said it's backup as we've been using it for the last 20 or 40, maybe 60 years, but the medium is just a little bit different. And Azure Site Recovery is a mechanism where we allow you to recover a virtual machine. So the main difference is that with backup, you're going to restore. With Azure Site Recovery, you're going to recover from a standby system. And I'll walk you through some details for each and one of them from here on. So Azure Backup, quite straightforward, I guess. It helps you in data loss. Now, why is it important? Because you want to make sure that you don't lose data, right? If you're like a finance organization and you have to go back to your customers like, oh, could you wire the money again because we lost the transaction? It's probably not really good. Or if even out of Microsoft, if we need to come back to customers like, oh, thank you for running your Azure SQL database on our platform, but oops, we lost it. That's not really the good message. Now, quite important, out of Microsoft, we don't cover backups for you. So we offer you the service, but we don't have the backup responsibility. obviously we're going to make sure that the service is running. But outside of that, data loss is painful for the business. It's painful for your brand. And also think about, lately, unfortunately, happening more and more, where you're losing data because of malware attacks or because of crypto locker alike scenarios. And that's where you need to have something to allow you to recover from. And funny enough, even in the 10 years of public cloud, during almost each and every training, I have to convince customers that Azure by itself, like AWS and Google Cloud and all the other ones, are by design not taking backups. You, as the customer, you need to integrate it in your solutioning. So what is Azure Backup? It's a backup solution as you know it. It's backup as a service, so you don't have to deploy anything. And on top of that, and I'll show you in a few demos, it comes with security in place. It comes with monitoring tools integrated in the platform, and it offers you RPO, RTO optimization because it's not requiring any manual tape handling, for example, where some organizations out of compliance are relying on a third-party data storage partner that's literally picking up the tapes Friday afternoon, bringing in some new tapes Monday morning. You're going to take the backup and they're picking them up. But it also means that when you need to run a restart from like a month ago or maybe a few months or a year ago, that it takes a while before they actually provide you the backups. And then you still need to run the backup itself, which is quite time consuming. Now, since Azure Backup is not writing to virtual tape drives, it's all storage based, it means that it's a lot faster. So that's where the lower RPO, RTO comes in. And since it's running as a service, no admin overhead, no management, or not too much management, it's also lowering the overall TCO. So that's a little bit what I mean by this one. So zero infrastructure with a little outsider that I'll talk about. Lowering TCO because you don't need to invest in expensive tape drive, expensive tapes, expensive robots, no physical components. So it's a lot harder to break and so on. And that's where you could use Azure in any scenario as a trusted environment. Now, what I mean by in any situation is where you can use Azure Backup inside cloud. So if you're running Azure VMs, if you run Azure Web Apps, Azure SQL, Azure Service, something, we provide you an integrated backup solution. But on the other side, if you're maybe somewhere in between or you're totally on-prem, you could still use Azure Backup. So it's an end-to-end hybrid scenario. So the first step into Azure could be that you're going to enable Azure Backup and then later on Azure Site Recovery for VMs and still keeping everything on-prem, but only moving the data to the cloud or moving the backup to the cloud. And obviously, once you're in cloud, again, you still need to provide your backup integration there. And you can choose, so probably somewhere halfway through, then we're back here, you're going to come up with a scenario that once you have your virtual machines not running on-prem data center anymore, but moving in Azure, you need to swap your backup configuration. And technically, it might only be a little switch that you need to set, and that's all it takes. So there's no downtime, there's no super hard configuration. So that's I would say the core idea. So on-prem, moving to cloud, anything that's already running in cloud can be integrated as well. And Azure Backup by itself, so it's offered as a service, so you don't need to deploy any complex infrastructure, not losing time, no updates, it's all managed by itself. And it comes with quite a lot of dependencies, but it's all relying on Azure standards. So Azure Backup default scenario, the only option you have is Azure Storage. Now I just talked about Azure Storage. If you want to make sure that your backups are available in any situation, like if one region is down, the best practice is store the backups in a different region. And if region East US is down, yeah, you can still recover them from Central US. That would be the idea. So that's where the resiliency availability comes in. Next to that, you can then define data tiering. So you could come up with a hot and cold and archive backup scenario, like the typical daily, weekly backups are stored in the same region, monthly backups or yearly backups up to 99 years for some funny number. It means actually that your great grandkids can restore your SQL database you're running today. But it also means that there's a lower cost impact because the lower the data tiering you use, like archiving storage, I think the only reason why we're not offering it for free is because legally we're not allowed to offer it for free. But technically, it's really that cheap. And outside of that, you got user authentication. So you need to identify in the platform, you need to have the correct Azure admin permissions, like the backup contributor role, and integrating with other services in the platform. And then the monitoring part, I'll show you out of Azure Monitor, Azure Log Analytics, or just using the portal or REST APIs if you want. So plenty of options there. And back to the baseline, no matter where your workload is running, in the cloud, on-prem, somewhere in between, you can use it. And how you can use it in a couple of different scenarios. So the first one is traditional conventional backup, where you have your virtual machine workloads and you're going to enable the backup service and taking snapshots. So similar to what Windows backup has been doing for 15 years, similar to what Veeam backup is doing, similar to Legato, HP Data Protector, Symantec, and all the other traditional backup tools. But the thing is that you don't need to install any servers, but you could use it. So that's what most customers are doing in scenario one, moving the workloads to the cloud, running VMs, and enabling built-in Azure backup. And in the meantime, we got some more fine-tuning, more specific workload-based backup scenarios, where obviously SQL is one of them. A lot of customers are still running SQL inside virtual machines. And what it allows you to do is the exact same thing, where we gonna provide internal backups, snapshotting on the virtual machine, from there moving to backup storage and relying on the backup service that I just talked about. And it comes with no infrastructure, just an agent to be deployed and easy to use.
Hey, Peter.
Yeah, go ahead.
Hey, Peter. Sorry to interrupt. My name is Ashish. I have a question.
Mm-hmm.
So, in case of a ransomware attack, right?
Mm-hmm.
How like what are the things which comes by default to support like a recovery in case of a ransomware attack for incident response? You know, a VMware, a particular network got attacked with ransomware. VMs are getting encrypted now. Like overall, all the data is getting. So what are the things which we can do to look at not only from the VM perspective, but also making sure that like where to look for even the backup, whether the backup themselves got encrypted, like the VM data got encrypted. Now we are making snapshot, but now snapshot also got encrypted. You know what I mean?
So that's where the recovery would be twofold. So you have the backup, and next to that, I would also recommend Azure Site Recovery. Mm-hmm. Now it's not going to save you for the full 100%, but I'll talk about ASR later on. But obviously, if you have the backups, and I'll show you in a demo in the next minute, then you got the different versions, right? So if you have like a daily backup, and you know that, like let's say last night you had an attack with ransomware, you still have the backups from last week, and those will not be infected. So then you just run the restore from the last backup that actually works. And yes, it means there's data loss, and that's where maybe site recovery could help you as well.
Okay, thank you.
And it's not a guarantee, but when you deploy Azure VMs, the recommendation is to also inject an anti-malware solution like Windows Defender, or a few other ones. We do support quite some vendors there that you could run on top of the Azure Virtual Machine stack. So
right. But the ransomware is always evolving. Like if people
Windows
use.
Defender is evolving as well.
Yeah,
No, but I
sure.
get the point.
Yep.
Yep. So another scenario is Linux machines, and the main difference there is that for Windows, pretty easy no matter what kind of workload you run. SQL is a particular example because we do have a specific backup agent, but all other Windows VMs are relying on the shadow, the VSS admin, similar to your on-prem VMs, exact same thing. And the same what all backup products are doing. So it's actually a little service on the Windows kernel that allows you to take a backup of an open file. That's mainly what that engine is providing. Now on Linux, it doesn't work in the exact same way because the operating system is not providing that capability. So what you need to do there is running pre-script, depending what the VM is doing. Obviously, if it's a web server, where there's no real dynamic movable files, it should be fine. But if it's a database server like running Postgres, MySQL, maybe Oracle, then the recommendation is to run a pre-script, freezing the database in a backup mode, and from there taking the virtual machine backup snapshot and running a postscript to unlock the database again, something like that. But the scenario is the same, so nothing's really changing. And a little bit on the architecture. So I'll walk you through this scenario in a live demo, but you start with creating the Azure backup service. So it's already there. You configure a backup job where it's mainly linked to policies like I want a daily backup, an hourly backup, I want a weekly backup, and a grandfather, father, son concept. So the long-term retention backups are also covered. Next, we're going to create snapshots of the running virtual machines or even offline VMs, obviously, if they're not running after business hours. Copying the 4 terabyte is already outdated, so I think it's up to 8 or 16 terabyte in meantime. And from there, we're going to move them into a secured recovery vault. So that's an encrypted location, and it supports up to 1,000 VMs in the same vault. So you could create like a one central backup location, a little bit like the trusted external backup partner that was picking up your tapes. They're also going to store it in a secured vault, and we're technically doing something similar. And in between, it's obviously using encryption. So if you have on-prem servers, the backup is encrypted on the on-prem system, and from there shipped in an encrypted way to Azure Recovery Vault. If it's running on Azure, it's also encrypted. And in meantime, you can also bring your own keys there. So it's using or the Microsoft built-in keys. And in meantime, we also support the bring your own key scenario. So that's pretty much it on the backup option. So I'm going to show you how to enable backup. So I got a series of virtual machines up and running. And from here, you go to the virtual machine, you select backup, and it's already recognizing some settings. So I already have a vault. So if I want to use that one, not in this region, you create a new one. You define a policy where the default is daily backup. But if you don't like it, you can create a new policy. I want to run it every day or every week. When you want to schedule it, how many recovery snapshots you want to keep, and what is your retention. So that's the daily, weekly, monthly, yearly backup. And 100% the same than the Veeam, Symantec, HP Open data protector that we've been using for I don't know how many years. And that's pretty much it. Then you enable backup. I'm using the portal, but obviously this could be scripted with PowerShell, CLI, ARM templates. And once you have it up and running, I think it was this machine. Yep, it's allowing you to run the backups. So I deployed this one only last night, and in meantime, it's taking 2 backups. Now, what Azure Backup as the software tooling, if you want, is trying to do is taking backups in different scenarios. So we got application consistent, and that's the default, and you don't have to do anything for this. But what it means is that we're going to make sure that we have the system disk, we have the data disk, and the data is consistent. If for whatever reason the application workload is not supported, because not all software obviously allows consistent backups, then we're going to move to a file system consistent. And that's a guarantee that the data itself is there. So your database, your, I don't know, open license files or anything will be part of the backup, but it might be that you need to recover them, that you need to, I don't know, flag them to be available again after a restore. And crash consistent is worst case scenario where we do have the backup, but it's no guarantee that the files are still usable. And this is typically the operating system where the kernel itself or the boot system actually is not starting up anymore, but then you still have the data backup partitions. So 3 scenarios, and obviously we always try to go for the consistent one. That's backup. It's nothing harder than this. It's already baked in each and every virtual machine. There's a bit more, well, it's not a complex way, but you could go to new Azure resource, search for backup. And for some reason I lost my cursor. Nice. Creating a new vault, and then from there adding the vault into, or adding the VMs into the vault scenario. But if it's only like one VM, or you don't really mind repeating the same process, you could use it in this way. Now, obviously, more important is not taking backups, but it's testing restores. So what it means is you can run your testing. Worst case, you have to use it in a production environment where out of Azure VMs, we support restores in a couple of different ways. So one is restoring individual files. What we are doing there is actually presenting you the disks as a mount point. On Windows, you need PowerShell and you need a Windows server to actually run the restore. So you cannot run this from a Linux Ubuntu client, for example, or even Windows 10 is not supported. You need to run it from a management station. And it's mounting the backup disks and allowing you to copy the files, or restoring the disks and not restoring everything, or the other option is restoring the virtual machine config, which is a separate Azure resource, and restoring the data as well. And then something new is literally running a disk swap. So instead of restoring, which is still time consuming, it's a lot faster than tapes, but it's still taking a while. You can just do a disk swap. So you're not really replacing anything. You just tell your Azure VM configuration, like, please give me my backup disks. And in 5 to 10 seconds, you're going to have your system up and running again. Go back to my virtual machine. Let's see if I zoom in. Oh, that's really cool. So I lose my cursor when I'm zooming in, and I get it back when I'm zooming in again. That's good to know. So back to my backup scenario. And since I do have backups, I'm going to run a restore, asking me what do you want me to restore during this given time frame. You can filter on the different options. I only have 2 of them, so quite straightforward. And from here, you're going to define what you want to see happening. So creating a new one, restoring one. So I'm going to create a new VM. This is the web VM restored in the same resource group, or maybe a different one with maybe a different network, or the same, and so on and so on. So quite straightforward. And running the restore. I'm not going to wait for it, obviously, but I keep it running in the back end. Hopefully by the end of the session, I can actually show you that it's running. Now there's another scenario. So this was Azure running VMs. You could do the same for on-prem running servers where you need to deploy an Azure backup agent, but that one only supports files. So in my opinion, a little bit useless. And that's where you can move to a full hybrid backup solution. So what you need to do for that one is deploying an Azure backup server. Maybe anyone remembers System Center on-prem tool where you got Data Protection Manager, DPM. Azure Backup Server is the cloud alternative from Data Protection Manager. And even in the documentation and sometimes in the screens of the tool, it's still called Data Protection Manager. The main difference is that you, instead of the DPM scenario where you have backups to disk to tape, you're now going to backup to local disks on-prem and replicating to Azure Backup Vault. So the scenario what I talked about before is the exact same thing. The main difference is that now you're deploying a full-blown Windows machine, installing backup server, and connecting all the backend to the cloud in the exact same scenario that I already talked about. Another interesting one is something new using Windows Admin Center. Now it's not really, I would say, built for enterprise environments, but something you see in like a SMB environments or maybe in a branch office from a larger enterprise multinational organization. And I'm pretty sure you all remember Server Manager on Windows machines. It's quite slow, it's not that intelligent, where almost, I think 18 months back, they moved to a nicer look and feel. So it's a browser-based admin console where you could all come up with using a gateway server. So the first server you deploy in a branch office, for example, or on which you install Windows Admin Center, that could become your gateway. And from there, you can use some hybrid Azure functionality like Azure Backup, the Azure monitoring capabilities, and a few other ones. So it's like a little upgrade from the boring, not that intuitive server manager to a web-based portal, which also means that you can connect to it from about anywhere, and you don't really need to run any complex tools besides installing the WAC admin tool, but that's literally an MSI package. So what it allows you to do in this scenario is deploying Admin Center on one machine or all of them, helping you in server protection, backup to the cloud, ransomware obviously is covered, running on full Windows, running on server core, and you're going to manage everything from within the Admin Center, or you're going to move it to a cloud-based scenario with some screenshots, but I hope I can show you in another live environment. So this is my virtual machine. It's running somewhere, and I installed Admin Center. The first time it's going to ask you for admin credentials. Next, it's going to ask you to register with your Azure backend. It's going to create a service principal like an Azure AD service account, and from there you can continue the configuration. So it's connecting to my Azure subscription, and it's going to read out information. So based on my backup environment, it's going to offer me some defaults, and it's emphasizing that this is the Admin Center Vault. If you don't like it, you could deploy everything first on Azure, but it's bypassing a little bit of the ease of use for SMBs and branch offices. So it's going to create a new vault, a new resource group, and maybe I keep this within my region, North Europe. You can flag what you want to backup. So it's literally next, finish, and done. And you need to provide a passphrase that's going to be used for the base64 mechanism to provide encryption. I'm still not capable of typing in a complex password and talking at the same time. So we're gonna copy some data. We want some retention settings. And what else do I need before I can apply it? You're connected to Azure, that's good. All the settings are there. What am I missing? There should be apply.
Your passphrase
Does not meet length requirements. Okay. That's better. So this is running an automated deployment technically, but it just looks a bit nicer. And that's all it takes. So this is again going to take a little while. It's going to create that resource group. It's going to create a vault service. And from there, running a backup job and starting the backup. So I'll keep this running. It's just flipping from different status. And that's backup. So from here, you can add additional security options where it's about protecting. So if you want, I'm not going to demo, but if you want, you could add security like multi-factor authentication into your backup option. So whenever somebody wants to run a restore, that they first need to re-authenticate, although they're already authenticated on the platform. You could integrate role-based access. So instead of having full admins, you could create a user account. Like my admin, Peter, I don't really trust him. And he's only getting backup operator permissions, which allows me to manage the backups, but I don't have enough permissions to actually create new backup jobs, for example. So a little bit like the tape monkeys, as we call them in the 90s. Then the monitoring part, the recovery part. So a lot of it, what I already showed you. Email integration, Azure Monitor, portal-based integration. That's all part of the advanced security options. And a couple of screenshots. So that's all out of the box. Which means, so the backup monitoring from here, I could go back to my backup vault, get a lot of the monitoring capabilities from here. If I want to get a view on all my backup jobs for the web server, SQL server, I can see that the web VM is still in restore mode. So that's all covered here. You can filter, you can create nice looking dashboards with pie charts and everything. So quite straightforward. Configuring backup alerts is another one. I don't have them because it's only a demo setup, but what you would do here is creating alerts that, for example, as long as backups are successful, you don't have to watch. If a backup is failing, that's where you're going to jump in. That's the main idea. And that's backup for VMs. I'm going to do a little time check. Nice. So from here, the other option is backup for non-virtual machines. So got two options, PaaS and SQL. PaaS is web apps, where I'm going to quickly show you how you could use it. And the same for SQL. So if you have a SQL Azure, where you want to run a backup restore, it's supporting backpack files from on-prem to Azure. So you could use it as a migration tool as well. Or you could integrate Azure Backup. That's this one, where you can enable Azure Backup within the Azure SQL service, and from there allowing you to run full backup restore operations. So within PaaS, taking web apps as an easy example, I got a website up and running. It's trying. I'll keep it running. So what you can do, similar to the virtual machines, make it a little bit bigger. So you dive into your app services, you configure backup, you define what backup mechanism you want to use. You enable it, schedule backup once per day or every couple of hours. What's the retention you want? And if your Azure Web App service is connecting to SQL, Azure, or MySQL, you can integrate that as part of the same backup job. So once you have your backup, obviously you can run the restores as well. You can run the restore into a new web app plan. You can run the restore to storage, so where it's going to copy the content but not spinning up a new web app, overriding the existing one or creating a new one, and that's pretty much it. So next, finish, and offered as a service. Same for SQL. So I got SQL Azure database. From here, you dive into the backup settings on server level at least. Where is it? Backup. Come on, backup. Manage backups. There we are. So by design, without doing anything, although I told you in the beginning that Microsoft is not taking ownership for backups, we actually do for SQL Azure. That's like the only service that we offer built-in backup. But the built-in backup is 7 days. So that's where it's probably a bit better to manage it yourself. But what it means, this is your running backup database, and you're going to configure retention. That's all. So similar to the backup for VMs, it's daily, weekly, monthly. That would be the idea. And it's allowing you to recover the same database on the same server or to a different server. Could even be a different region. And that's what you define from here. So restore database. What do you want to restore? The real one or the real-time one or the longer-term one? The name of the database. What's the sizing of the database, and taking it from there. And this again could be automated using PowerShell, Azure CLI. So, and that was my workload. So that's all backup, virtual machines, IaaS, PaaS, web apps I already showed you. I don't got any detailed slides on that because it's 100% the same as your backup virtual machine scenario. So in the last 10 minutes, I'm going to walk you through disaster recovery. So what is disaster recovery? It's giving you the option to recover without running a restore. So typically having a standby system. I got, first of all, a repeat. It's not the same as high availability. So we need to come up with something else, where a question could be, what happens if your region is down and you don't want to deploy everything like over and over again? Where you could switch between a disaster recovery scenario or deploying everything fully highly available redundant, where hopefully you go for recovery options. Why? Because again, high availability is quite expensive and literally losing resources. And then some details on what is a disaster. So a lot of things can go wrong. System failure, it's still the highest number. Natural cause is only 20%. Cyber attacks are coming up more and more. So the ransomware question that we had earlier is probably in that 15%. Where backup is not the same as disaster recovery. So with backup, you're going to build it to allow you to restore data. With disaster recovery, you're going to integrate it that allows you to easily recover, and you don't spend time on waiting for the restore. That's the main idea. Where based on historical data centers, you could come up with an architecture like this, where you're going to build your data center, you want high availability, so you're going to deploy it twice. You deploy VMware Hyper-V, so you're going to deploy them twice. You deploy virtual machines inside, you're going to copy them twice. Maybe using VMware replication, maybe using complex storage replication. And on top of that, you need geo load balancers to redirect users or customers from one data center to the other. And that's vendor lock-in, it's expensive, it's outdated. So that's not what we're gonna do. So from here, we're gonna move to Azure Site Recovery with a couple of marketing slides. that I'm going to skip for now. I'll walk you through some more technical scenarios. All nice to know if we would have a bit more time. So what is Azure Site Recovery? It's a built-in service, so you don't really need to deploy anything besides an agent or a site recovery server in the source environment if it's not running Azure. That allows you zero data loss. There's a replication sync every 30 seconds. And technically, obviously, depending a bit on the workload, even in case of a disaster, depending on the disaster, of course, we're going to replicate to the other side and you don't have any data loss. The replication itself goes quite fast, which also means that the downtime is quite low as well, typically a few minutes. And we support Hyper-V, we support VMware on-prem, we support Azure between regions, and we support Amazon. So if you have AWS VMs, you could use Azure as a disaster recovery site or the other way around. And the same for on-prem, using cloud as a disaster or using Azure Prime and going back to on-prem would also work. And next to that, it also allows you disaster recovery testing. And what it means is that, first of all, not all organizations are running a full end-to-end data center test. And what we offer you is a replication of your already replicated VM. So we're going to start it up, allowing you to test network connectivity, allowing you to test virtual machine connectivity, everything. And if all goes fine, you flag like, yes, I did my testing. And that's without any business production workload impact whatsoever. So a lot different than what most solutions are actually doing today. And then you could come up with a scenario where you got source on the left, Azure target on the right-hand side, where you're going to replicate everything. So easy said, you deploy ASR service on Azure, you deploy an ASR agent in each and every virtual machine or physical server, or you deploy it inside VMware, but then it's a full ASR server software. It's not just an agent, or you integrate it with Hyper-V, and you're going to enable replication for everything. So from here, each and every server is starting the replication, and you can define the timing. So Azure to Azure is giving you real-time replication. If it's hybrid from AWS, VMware, Hyper-V, you can specify 30 seconds, that's the lowest, 5 minutes or 15 minutes. So depending a bit on the workload, you're going to pick one or the other. Like a static web server, you're probably not going to replicate every 30 seconds, but a database server probably every 30 seconds. So it's going to collect all the changes for each and every of the servers, replicating the data and storing it offline. So it ends up here 30 seconds after the new replica, new replica, new replica. And from there, allowing you to keep your virtual machines in sync. Now, quite important, the VMs on Azure are not running at that time. And that's where the big benefit comes in. Or you could mix and match, where you add site recovery for certain workloads, but not for all of them. So like SQL, MySQL, Oracle, you could run a cluster. So you're going to have high availability, SQL running left side, SQL 24-hour, 27 running on the right-hand side, and only using site recovery for a few other ones. And then ultimately, so a little bit what I explained, you're going to replicate from source to target. And if you want, you could, again, automate everything. So just two sample snippets, and I think they're a bit outdated as well. But the idea is that you could automate it. Now, why is that important? Because out of Azure Site Recovery, it's not an automatic failover. So it always requires a manual trigger. So with that, one of the last demos where I'm going to show you how you can enable it, and next to that, how you can run a failover. So the starting point is almost identical to the backup configuration I showed earlier. So back to my VM, I go to disaster recovery, and a nice looking wizard is going to guide you through. Now it's detecting that my machine is running in West Europe, and you can replicate within the same geography, but not outside. So from my prime server, West Europe, I can replicate to North Europe, to France, to Dubai and South Africa, because it's all based on the same EMEA geography. I cannot replicate to APAC, I cannot replicate to the US, for example. Next to that, you can specify where you want to create your DR resources. So an individual resource group, a specific DR network that could be somehow offline, like not connected to the rest of the network, not having VPN express route connectivity whatsoever. That's what you define here. You push the start replication button and it kicks off. It's going to start with creating the recovery vault. Next, it's going to deploy the agent. It starts the full replication. And once the replication is complete, you can start running the failover. So that's what I did for my web VM. So after everything is in sync, it's going to try to replicate all the time. So Azure to Azure is real time. Hybrid is 30 seconds, 5 minutes, or 15 minutes. You can choose. So from here, you run a test failover. So that's where it's going to create a clone of your already replicated web VM, starting it up and allowing you to validate, do I need any DNS updates? Do I need network connectivity? Do I need any firewall settings and whatnot? Or running a live failover. So honestly, I didn't try this out yet. So I deployed it yesterday, did a test failover, but not a full one. And it also allows you to specify what do you want to replicate. So coming back to the ransomware question, that's where you would pick an older version, right? Next to that, you could specify the lowest RTO or RPO. So depending when the disaster happened, you would pick one or the other. So I'm going to try the latest processed one, where it tells me your recovery point objective, like what is the point that allows me to go back to, is 3 minutes, which I think is a lot better than what most other tools can offer you. So from here, it's kicking off. So back to the monitoring integration, it's going to run. And what it's going to do here on the fly is shutting down the VM. Same scenario in hybrid. On-prem, it's going to shut down your virtual machines. We cannot shut down AWS because we're not really getting into that part of the platform. So you would need to shut it down yourself. And it's going to synchronize the final changes, making sure that there's no data loss, starting the failover, and starting the web VM on the other side. So I'll keep this running. If you got any interest to see the same scenario for AWS to Azure, I have it in screenshots. So I got like 70 slides with all the steps from this is how you configure the recovery vault. This is how you deploy the full ASR software in AWS. This is how you configure it, replication, configuration, everything. And if you're interested, let me know. Send me a tweet or an email, and more than happy to provide you the slide deck on that one. So with that, we have only a few minutes left, I guess. Yep. For any questions. But before that, since maybe some of you need to go, I don't know how your lunchtime is arranged, but I promised you a little gift all the way at the end. So quite important. I'll provide the deck afterwards, but if you want to play with this right away, take a copy of this URL. And what it is a full lab guide on how to configure all the different Azure backup scenarios for virtual machines, Azure backup server for the hybrid scenario, backup of web apps, backup of SQL, and it's, I don't know, 160 pages, I think, with all screenshots, everything, connecting to pre-configured Azure ARM template where you can deploy your backup scenario. So it's going to deploy a whole bunch of VMs that you can just use and start playing around with. I don't have it for site recovery, but it shouldn't be harder than that. So that's my little gift.
Can you put that link in the chat?
I can actually do that. That's a good idea. So it's grabbing some ARM templates from my, I don't know, GitHub or Azure Storage. And where's my Skype? Up here. Oh, provide my email address and Twitter. LinkedIn is PDTIT, Facebook is PDTIT. I'm not on Instagram, I'm not on Snapchat. And with it, I'm switching one slide back to any questions, feedback, concerns. If you have a bit more time, I can wait until this is, oh, nice, it's already done. Which means if I go to my virtual machines, I got now 2 web VMs. My production one is down, and my recovery one is running in an ASR group in a different region. And this was even from Central US to East US too. And the web VM is running. So if I go to where do we show the diagrams? Insights, metrics, I don't remember. We used to have some nice diagrams where you could see that a machine was running. It says running up here. So you have to trust me that it's running. But that site recovery, it's one of the really nice tools. Even if you want, send me a mail or a tweet. If you're interested in a 4-year outdated book on backup and site recovery, I'm more than happy to provide it. It's funny enough, it's still not really outdated. Only the OMS monitoring part is totally replaced with log analytics. But backup site recovery has not really changed in concept. Even the portal has been quite static on that part. So if you're interested, feel free to let me know. I'll be more than happy to share. I'm not making money out of that anyway. So that was probably what I wanted to cover.
Thanks a lot, Peter. I see that. Let me just see if there are any questions in the chat. I think there is one. Does ASR work for the Azure Kubernetes cluster?
Yeah. So I never tried it out myself. And what I mentioned at the beginning is that there's no documentation on how to create a business continuity for Kubernetes clusters using ASR. But the way it works, and that's a big part to just how Kubernetes is working. So the default when you create a Kubernetes cluster is that it's running in a high availability set. If you want, you could move to an availability zone. So multiple nodes of the cluster will be stretched out across different parts of an Azure region. And you deploy it takes about 10-15 minutes typically for the having the cluster up and running. And worst case, if you lose the cluster, you're going to redeploy it. Next to that, you have your Helm charts to push out the images. Maybe you move it into a DevOps-like scenario. That would be the alternative. So no ASR, but on the other side, but I would need to try it out because it's not documented. So it typically means that it's not supported. But since it's based on a Ubuntu Linux machine, maybe it works, but I wouldn't recommend it in a production environment.
Yeah, I think there are definitely some more configuration options. I'm not quite privy of how the Azure AKS, right, kind of works internally. But yeah, there are options like doing a stretch cluster, putting your master nodes across regions and worker nodes across regions, and then kind of using some labels and stuff to create some affinity for the best case and then kind of fail over in the worst case. So
Yep. And well, again, out of what Kubernetes offers from the Kubernetes concept, you're not really thinking in disaster recovery, because in the end you're going to redeploy the container and that's it. So I would more work towards a high available container registry across multiple regions. Deploying it in availability sets or zones, and not moving to like a ASR scenario. Containers are probably starting up faster than replicating with ASR anyway. So with that, I'm gonna close down and I'm gonna give you your afternoon time back. So I would say thank you for participating, for listening. Feel free to reach out if you got questions. And Niraj, thank you for allowing me to present on one of my passionate domains in Azure.
Absolutely. No, Peter, I think just getting someone as an authority on the DR and the BC topic, and I think someone who has written a book on it, I think I can just count those people on a single hand, I guess. And you're definitely one of them. So it was very, I think, insightful, and I think you presented it in a fairly digestible, simple way, kind of steering out through all the complexity which we hear as an approach to disaster recovery. So this was very helpful, and looks like there are a lot of people agreeing with me, attendees agreeing with me on that. So thanks a lot. This has been wonderful, and we hope to get benefit from your expertise in future as well. After you kind of infrastructure as a code book, probably we can have another session on that.
Sure, anytime. Don't hesitate.
Okay. So thanks everyone for joining. As the last thing, I would say that if you have not already done, I would encourage everyone to join our Slack channel. Now that's a newly formed channel which we are using to, rather than just doing emails, right, which at times can interrupt. And I think if you want to reach out in addition to all the community members with any of your queries, I think just AKS DR, right, could be one of the topics. It makes it a lot more interactive for us to exchange our thoughts and ask questions and to benefit from the expertise which we carry as a group, right? So if you're not already done, I can put up the link. Just give me 1 second here. I'll add the link in the invite here, but it's also on our meetup page. So this is where you can join the Slack channel and collaborate with the rest of the community members and ask anything technical, non-technical, just the hobby projects which we were discussing earlier. If you need any assistance on that, or just in general, right? I guess just getting to know people in the local area, I think it always helps. So with that, once again, I'd like to thank Peter, and we'll try to take the recording, post it on YouTube, for your future viewing as well. And hope to see you next month. Next month, again, it's a very interesting topic. It's something which one of my ex-colleagues has built as a learning tool. Like in this lockdown, he was trying to get up to speed on the machine learning stuff on the Azure platform, and he kind of created a simple project to analyze audio files, recordings of the from the hospitals and so on, or the medical facilities, and then try to determine that what is the sentiment analysis for that region or for that hospital, as to pay, are the patients really getting cured, or there are like there is a surge in the spread of the virus and stuff. So I think that's going to be fairly interesting. The details are there on our meetup site. So hopefully all of you can join that as well. With that, enjoy the rest of your day, and talk to you next week, next month. Thanks everyone, and thanks Peter.
Peter, everyone.
With that, I'll just stop.